Welcome to a crucial topic in advanced AI development: agent specialization and expertise validation in AI systems. In today's session, we're going beyond basic model training to explore how we can build AI agents that not only perform tasks, but also understand their own limitations and justify their decisions. By the end of this lesson, you will be able to understand why AI agents need expertise validation, moving past simple confidence scores. You'll also be able to identify the core components of an expert validation system, recognizing the building blocks that make these intelligent agents truly reliable. Furthermore, you'll grasp the architectural layers for robust validation, seeing how different checks combine to form a resilient system. And finally, you'll be able to recognize real-world applications of specialized validated agents, understanding their practical impact in critical domains. Let's dive in. Let's start by addressing the expert problem. Most AI systems today act with unwavering confidence, even when their underlying data or knowledge is insufficient. Think of a content recommendation engine suggesting something with 95% certainty despite limited user interaction data. This can lead to misleading or even harmful outcomes in critical applications. Real expert systems, however, must inherently understand and convey their limitations. They need to know when to be cautious or even when to defer to a human. To solve this, we introduce a core architectural component: the validation pipeline. It processes requests through 4 critical layers: domain expertise check, ensuring the agent actually knows about the topic; source validation, cross-referencing claims against trusted information; confidence scoring, quantifying certainty with clear evidence; and audit trail generation, recording every decision for review. The output of this pipeline is often encapsulated in a structured format, like a validation result data class, which captures the confidence score, validated sources, expertise level, and an explanation. This ensures that every outcome is not just an answer, but a justified answer. A truly intelligent agent relies on more than just a static database. It needs a dynamic knowledge management system. Unlike traditional data stores, our knowledge base actively tracks the provenance of information: who added it, when, and from what source. It also monitors validation status, like whether a fact is peer-reviewed or disputed, and even usage metrics to understand how often a fact is cited and its accuracy in past predictions. Crucially, it tracks expiration dates, flagging when information might become stale or outdated. This dynamic approach supports a robust expert system design pattern, which employs a 3-tier validation approach. First, quick filters immediately reject obvious mismatches, saving computational resources. Second, deep analysis performs detailed validation for complex queries, engaging with the dynamic knowledge base. Finally, human escalation flags uncertain cases for expert review, acknowledging the system's limits. This layered approach is often encapsulated in methods within an expert agent class, where logic like has domain knowledge, find supporting evidence, and calculate confidence work together to produce a reasoned expertise result. Beyond just providing an answer, a truly specialized agent offers explainability. Every decision it makes includes a human-readable explanation that details which sources were consulted, why certain sources were trusted over others, and even what gaps exist in its knowledge. This transparency builds trust and allows for critical review. Complementing this is the audit trail implementation. This system captures every decision point, from the initial input analysis to which knowledge sources were retrieved, through each validation step, the specific decision logic applied, and finally, how the confidence was calculated. It's a comprehensive log of the agent's thought process. Let's look at a real-world application: a technical documentation agent. This agent can validate code examples against actual APIs, cross-reference implementation patterns, and flag outdated information. Imagine asking it for the latest authentication pattern for a major cloud provider. It would check its knowledge, validate against live API docs, provide confidence scores for code snippets, and explain its recommendation. For production, we consider version control for knowledge updates, access control for different expertise levels, performance with parallel validation, and continuous monitoring of accuracy metrics. We've covered a lot of ground today, and I hope you feel empowered to build more robust AI systems. To recap our learning objectives, we established why AI agents need robust expertise validation to move beyond simple confidence scores and avoid overstating their abilities. We identified the key components of such systems, including dynamic knowledge management and comprehensive audit trails. You now understand the multi-tier validation architecture that ensures reliability and explainability. And we explored a real-world application with the technical documentation agent, seeing how these concepts translate into practical, reliable tools. These principles are vital for building AI that's not just smart, but also trustworthy and accountable. Now, for your self-assessment, considering all we've discussed, how would you design a validation system for a financial advisory AI? Think about the specific challenges and critical needs in that domain.